Hello everyone, my name is Omar Lujano and I am a first-year PhD student in the House Lab at SDSU, and today I'm going to be talking to you about a project and question that I've been working on since the start of this pandemic. And that question is, do chemotherapy induce ECM or extracellular matrix alterations influence ovarian cancer cell survival? So to start off, ovarian cancer is one of the most lethal gynecological diseases with a 5-year survival rate of 25% using traditional therapy regimens. How does this traditional therapy regimen look in the clinic? Well, in the clinic, traditional therapy regimens involve high-dose chemotherapy over a short period of time. And what we see in that situation, especially after looking at residual tumors, we see there is a mixture of things, including a bulk population of cancer cells left over, depicted here. We also have activated fibroblasts, especially in this high-dose traditional therapy regimen. So we'll have a large proportion of these fibroblasts in this tumors left over, residual tumors. And we also have a high proportion of tumor-initiating cells. And as the name suggests, these tumor-initiating cells have the propensity to reinstate a tumor and essentially give rise to a new tumor. However, clinical trials, especially in epithelial cancers like ovarian cancer and breast cancer, what we actually see when we do low-dose therapy over extended periods of time, what we actually see is we will still see in those residual tumors are cancer cells. However, we will see less of these activated fibroblasts. So we do not have as many of these stromal cells activated when we do low dose. And also, importantly, we have less of these tumor-initiating cells, meaning, clinically speaking, if we have less of these tumor-initiating cells, we should have a lower propensity to relapse. Therefore, I am interested in understanding how in traditional chemotherapy regimens, we have this activated fibroblast, a lot of them as we see, and how they play a role in what we see. And therefore, what I'm most interested in is seeing how these traditional therapy methods activate a high proportion of these fibroblasts, which these fibroblasts, the biggest things that they do is they secrete a lot of ECM. So if you have a higher proportion of activated fibroblasts, you will have an increase of this ECM, and potentially this extracellular matrix is creating an environment that is allowing for more cancer cell survival. And therefore, what I've been doing in my lab is I've been taking fibroblasts and culturing them over 8 days. Over these 8 days, I have samples where these fibroblasts are not given any chemotherapy, high-dose chemotherapy as seen in the clinic, and others where there is chemotherapy. And so what I'm doing over this 8-day period of time is I am letting them secrete an extracellular matrix, right? A native extracellular matrix under these conditions. So in those plates where I have my fibroblasts with no chemo, they'll start to secrete a nice uniform extracellular matrix. However, in chemotherapy settings, we have what we see in the clinic. We have this very high proportion activated fibroblasts, and they are secreting ECM like no other. And so this upregulation of ECM is seen in this setting with chemotherapy, as we see in the clinic. After those 8 days, I am decellularizing these plates, and now I'm just left over with nothing but just the extracellular matrix. Now we can replate these matrices with cancer cells, so we can take our ovarian cancer cells, which I'll depict as OVC here. So we take our cancer cells and we plate them on these matrices under no chemo and those that had chemotherapy. And some preliminary data has suggested that the survival rate of cancer cells in matrices that were altered under chemotherapy, as we see in the clinic, have a higher survival. So what this suggests is that there is a need to also target the stroma or these activated fibroblasts, because they are also dictating the fate of the tumors left behind. And therefore, it is important for us to find ways to either stop the activation of these fibroblasts or decrease the amount of this ECM. And all this together, clinically speaking, we hope to have a higher increase of survival for these women. Thank you for listening.